For this section, we're going to have a bunch of vocabulary and a bunch of identities. So I have uploaded to Canvas these notes, and it basically, it's 4 pages long. I would strongly suggest that you download them. But I'm going to go through and explain what all of those mean. And then in this section for homework, we're going to be applying a lot of it. So the first thing we need to look at is the 6 fundamental trigonometric identities. So what we have is sine, we have cosine, we have secant, and we have cosecant, and we have tangent and cotangent. So these are operators. Okay, what is an operator? If I write this down, you know to add. Okay, if I write this down, you know to divide. If I write the abbreviations for these followed by an angle measure, you know to find a ratio. So these are operators, but we're also going to talk about their how to write them as a shortcut, because I'm not writing this all day long because math people are lazy. So first of all, there's a reason that I wrote them the way that they did. You'll notice that these two are friends because this says sine and this says cosine. Okay, these two are friends because they say secant and cosecant. And then these two are friends because they say tangent and cotangent. So these 3 sets, this set, and this set, are all called cofunctions. Okay, so the CO is important. So what we're going to do is this. So before I dive into this, we're going to do a quick refresher. If an angle is between 0 and 90 degrees, we call it acute. If an angle is 90 degrees, we call it a right angle. And if an angle is between 90 degrees and between 90 and 180, then we call that obtuse. I keep just throwing all these little equal things here. Sorry. All right. So 0 and 180 are straight angles. Okay. So now that I know that, I'm going to use the fact that acute angles are between 0 and 90. If I add up 2 acute angles and get an answer of 90, I find out that they are complementary. For instance, if I take an angle measure of 50 and add it to an angle measure of 40, these are both acute, I get an answer of 90. So these 2 angles are complementary. Okay, those 2 angles are complementary. So what about in radians? And I'm just going to keep this basic. If I have pi over 4 plus another pi over 4, so remember these are both 45 degrees, 1 pi over 4 plus another pi over 4 is 2 pi's over 4, which is a pi over 2, which is 90 degrees. So these 2 are also complementary. So now that I know what a complementary angle is, or what complementary angles are, notice it starts with CO. So what I'm going to find out is if the angles that are referred to between cofunctions are complementary, I can flip-flop those cofunctions out. And now I'm speaking a total foreign language, so we should probably back up and figure out what these things mean. So first of all, sine is going to be abbreviated as SIN. Okay, I'm going to turn that off. Is that better? All right. So that's sin. Cosine is going to be cos, because remember, we're lazy math people, and it's too hard to write the full word. All right, secant is going to be sec. Cosecant is going to be a weird one. It's csc. Tangent is tan, and cotangent is cot. So what I said before is that these things are operators. When you see these followed by an angle measure, so I'm going to use theta for an angle measure, just because I don't want you to get confused with x's. Okay, it's telling you to do something. So please take the sine of this angle. So I need to know what that's telling me to do. The result of taking a trig function's angle, okay, so taking the sine of an angle or the secant of an angle, the result will always be a ratio. The result will be a ratio. So we're going to come on down here for a second, and we are going to build a triangle. So here is my triangle. Look at him. Okay, and I'm just going to ignore that. I don't know what happened. All right, so I'm just going to say that this is going to be x, because it's horizontal. And this is going to be y, because it's vertical. And then I'm going to call this h, because it's the hypotenuse. Okay, so remember, the hypotenuse is the part of the triangle that's opposite the right angle. So what we're doing today is always going to refer to right triangles. In fact, what we're doing until the end of chapter 8, I think, or chapter 9, is always going to deal with right triangles. Okay, and then we're going to come down and say, surprise, we can do this with other stuff too. So bottom line is, when I ask you for the sine of an angle, so I have a choice here. I can use this because this is 90, okay? So, and that has answers too, but that's a surprise for later. Right now, for today, we have two angles to choose from. So I am going to use this angle. Okay, so that's theta. I could have used this one, but I'm going to choose to use this one. And what that means is, when I take the sine of an angle, I'm asking you to tell me the relationship of the opposite side to the hypotenuse. So it's a ratio. It's the opposite side to the hypotenuse. So this tells you to do something, and you're reporting an answer of a ratio of opposite to hypotenuse. Now you'll notice that the way I wrote this angle measure opens up to an opposite side of y. Okay, so he's y. Over h is your hypotenuse. So I can be a lazy math person, and I can also say that this is just y over h. Okay, cosine is going to be adjacent over hypotenuse. So when I ask you for the cosine of an angle, what I'm asking you to find out is, what is the ratio of the adjacent side to the hypotenuse. So if this is theta, I've got two adjacent sides. I've got two sides that this angle creates. And this side must be the adjacent side, because this side, by definition, is the hypotenuse. Okay, so this one is going to be adjacent. So I'm going to say ADJ over hypotenuse, which I could also write as x over h. I should have skipped lines, sorry. All right, and now I'm going to flip down to tangent for just a second, okay? Because something magical is going to happen with these other functions. All right, so I'm going to skip down to tangent. Tangent is going to be the ratio of opposite to adjacent. So when I look at opposite to adjacent, I get y to x. So those are the three hard ones to remember: sine, cosine, and tangent. The other ones are going to match up, so I'm going to highlight, okay? Sine and cosecant are reciprocals of each other. Remember, a reciprocal means you flip the fraction. So if I have 2/3, the reciprocal is 3/2. Okay? I know that cosine and secant are reciprocals. So I'm kind of organizing these in weird ways. And I don't have a different colored marker. Why don't I have orange? Give me a second. Well, my life just ended. Okay, so we'll just make a box. All right, so I'm going to use a red pen and make a box. We're not going to use a red pen because I already used red. We're going to use a blue pen and make a box and say that these two are also reciprocals. So I'm going to give you little hints as far as how I remember these things. Okay, the S's and the C's will never pair up with other S's and other C's. What did she just say? Sine and cosine, S and C, are cofunctions. Okay? Sine and cosecant, S and C, are going to be reciprocals. Cosine and secant, S and C, are going to be reciprocals. Okay? And then tangent and cotangent are kind of off by themselves and they do their own thing. So tangent and cotangent are not only cofunctions, which we're going to go into depth some more in a second, but they are also reciprocals of one another. Okay? So these are cofunctions, cofunctions, cofunctions. The pinks are reciprocals, the yellows are reciprocals, and then the blues are reciprocals. So if I know the reciprocals, well, I can go over here. If sine is opposite over hypotenuse, then cosecant is the flip of that. It is hypotenuse over opposite, which means it's not y over h, it's h over y. Okay? Secant and cosine are reciprocals of one another. And so cosine is adjacent over hypotenuse, which means secant must be hypotenuse over adjacent, which means that's going to be h over x. Okay, so again, just to because this is kind of a weird thing. People look as excuse me, as multiplication, and they'll say, oh, that's sine times theta. No, it's not. This is an operator. This tells you what ratio to take of that angle. What ratio to take of that angle. What ratio to take of that angle. So this is a package deal. Okay, and we're going to learn in chapter 8 how to undo all that stuff, but not today. Okay, so what I have is if tangent is opposite over adjacent, then cotangent is going to be the reciprocal. So he's going to be adjacent over opposite, which is going to be x over y. Okay, now notice on your handy dandy paper that I typed up for you. Okay, you've got sine is opposite over hypotenuse, which is y over r. I used r for radius, and we're going to learn more about that later. Just recognize that r is the same thing as your hypotenuse right now. Okay, so I've got cosine is adjacent over hypotenuse. I've got all this stuff typed up, and if you will notice, I put the reciprocals on top of each other. So this is y over r, this is r over y. Okay, this is x over r, r over x. This is y over x, x over y. So another way to look at these is a reciprocal is just the flip of a fraction. So go back to arithmetic for just a second. Okay, if I take 2/3 and I flip it to get the reciprocal, I get 3/2, correct? Okay, so I can do that same thing with a ratio. So what I want to show you is if I take 1 over, okay, 2/3. So remember, I started with 2/3. Okay, I want you to see how we get to 3/2. Because what I do is I divide 1 by 2/3. So when I do that, well, how do I divide fractions? I change that into 1 times the reciprocal of this, which means I get 1 times 3/2, which is 3/2. So what does this mean? This is just a way to remember that if I've got cosecant and sine, they're reciprocals of one another. Okay, so sine and cosecant are reciprocals of each other. because they are reciprocals, I can generate cosecant by taking 1 divided by sine. Okay, and then I got some identities over here. If I multiply a function by its reciprocal, I'll always get 1. So come back over here for a second. Go back to arithmetic. If I multiply a fraction by its reciprocal, I'll get 6 over 6, which is 1. Okay, so all of this is like coming at you hard and fast, I recognize. So before this video runs out, because I'm trying to keep it between 15 to 20 minutes, I want to talk about cofunction identities. So that's going to be found on page 3, and it kind of looks like a foreign language. So I'm going to break it down over here, and I'm simply going to say, so remember the cofunctions are the red pairs. Okay, so let's look at sine and cosine. So I'm not going to quite set up my triangles yet, but I am going to say this. If I've got the sine of 50 degrees, okay, and I add it to the cosine of 40 degrees, I look at 2 things, and I'm using these on purpose, because remember that 50 and 40 were complementary. Okay, I have cofunctions. Okay, so what that means is I look first at the angle measures. Are these angle measures complementary? Yes, they are. Okay, are these trig functions cofunctions? Yes, they are. That means what I can do is apply an identity, and because they are cofunctions, and this is kind of weird, I can change this to the sine. So I'm going to change the cofunction of the complement. Okay, so this is going to stay the same for a second. He's going to be the sine of 50. Okay, what is the cofunction of cosine? The cofunction of cosine is sine. And then you tell me what the complement of this angle is. What's the complement of 40? It is 50. Okay. Well, now I got a sine of 50 plus a sine of 50. So all I'm doing now is combining like terms. So I've got 2 sines of 50. Now, in this case, I'm showing you bare bones, okay? It's not always going to be, we may have to change things so that everything's in sine, or everything's in tangent in that case. So in that case, these would not have to be complementary. I just find the complementary, okay? So if I wanted to, let's try it again. So let's do secant and cosecant. So I've got the secant of 37 degrees. Okay, plus the cosecant of, oh my goodness, what's that going to be? 43. Is that right? 4 is 7, that's 10, this is 53. Look at me add first thing in the morning. Okay, so my first question is, can I apply something fun? Because a lot of pre-cal is going to be you looking and saying, what can I do? Instead of us feeding it to you like we did in college algebra and before, it's going to be a lot of, holy cow, what do I do? I've got a ton of options. What's my best option? Okay, so the first thing, because I'm setting these up intentionally, I want to look and see, are these 2 things complementary? Okay, so are 37 and 53, if I add those together, do I get 90? Yes, I do. So that was check mark number 1. Okay, look at check mark number 2. Are these cofunctions? Yes, they are. This is secant and cosecant. So what that allows me to do, and I'll change this one this time because it really doesn't matter. What is the cofunction of secant? Okay, the cofunction of secant is cosecant. And then what is the complement of 37 degrees? It just so happens to be 53. So I can change these things. I can flip-flop them out. And so now what happens is instead of using 2 different trig functions, I got the same trig function. And that just makes life easier. And now again, I've got one of these and one of these, which means I must have 2 of those. So I have 2 cosecants of 53. Okay, so I'm going to pause this video, and we're going to, not pause, but stop this video. And then we're going to pick up with a part 2.